Hi, this is Mrs. Myers, and today we are going to be learning Lesson 8.2, Special Right Triangles. There are actually two types of special right triangles. One is called a 45-45-90 triangle, and the other one is called a 30-60-90 triangle. Now these are special right triangles because they are commonly found in lots of shapes or parts of shapes. And so knowing the relationship of the sides of these shapes helps us sometimes to solve for a missing side. So we can think of this really as another way of solving for missing sides other than the Pythagorean theorem. Remember, the Pythagorean theorem, again, is with only right triangles, and it's when we know two sides of a triangle and we're looking for the third side. Well, with 45-45-90 triangles and 30-60-90 triangles, if we know the angle measures, we really just need one side, and then we can find the measures of the other two sides. So it really helps us, if we know the angles, to be able to solve for all the sides. So the first one is a 45-45-90 triangle. 45, 45, and 90 refers to the angle measures. If you have a 90-degree angle, which makes it a right triangle, it's possible to have two so you can have two 45-45 two angles that are 45 degrees. Now we know if these two angles are congruent, what kind of a triangle is this? If two angles are congruent, then the two sides would have to be congruent. So if you remember, this is an isosceles triangle. So this is actually an isosceles right triangle. It's a very special triangle. So the relationship of the sides are going to be helpful because isosceles right triangles happen all the time. In fact, an isosceles right triangle is half of a square, right? So just by the fact that it's half of a square makes it happen a lot in different figures. Okay, so what is the relationship of the sides? The relationship of the sides is that one of the sides we're going to call S. The side that's congruent to it is also obviously called S. Those are the two sides that are across from the two 45-degree angles. Whenever you have this situation, the hypotenuse is going to be whatever S is times the square root of 2. So if you have an example here, let's try a few of these. Here's a 45-45-90 triangle in 1A. The side across from this 45-degree angle is 9. So therefore, the side across from this 45-degree angle must also be 9. Hypotenuse is going to be 9 times the square root of 2, because the hypotenuse is always whatever S is times the square root of 2. So the way that I suggest that you approach these problems, okay, it's going to involve memorizing a diagram that says 45-45-90 S, S, S root 2. You have to memorize this relationship. That has to be memorized. Then, whenever you approach a problem that has 45-45-90, what I want you to do is label the sides immediately, just like this triangle that you memorized. So across from 45, I'm going to call this S. Across from 45 is also S. Across from 90 is going to be S root 2. Always. Across from 45 is S, across from 45 is S, across from 90 is S root 2. So now what you want to do is look at your diagram because they will have given you some information about one of the sides. In this case, this red side is the side they gave us a value for. Well, if we labeled this side S, because we know across from 45 is S, and it's also labeled 2 square root of 2, then we can just put an equal sign between them, and now we know that S equals 2 square root of 2. It's a little bit of a tricky one because we're used to seeing the root 2 in the hypotenuse, but here it's 2 root 2 is actually the value of S. So now we have to go to the hypotenuse and figure out what x is. Well, if S is exactly equal to 2 root 2, then wherever there's an S, we could replace it with 2 root 2. So this is going to be 2 root 2 root 2, because S is exactly equal to 2 root 2. So in this relationship here, I know this is a little bit confusing, but in this relationship right here, S root 2, we have to take out the S and replace it with 2 root 2. So this 2 root 2 replaces this S. But there's still a root 2 sitting here, this green one. So we have to put that in as well. So x, this side which is x, equals S root 2, right, S root 2, which becomes 2 root 2, it's S, and root 2, which is this root 2. So we get x equals 2 times, now, an important thing to learn here is that any time you have a value under a square root sign and then you multiply it by its exact same thing, root 2 times root 2 is just 2. Square root of 2 times the square root of 2. Multiplying them by itself is like squaring it. This is like saying the square root of 2 squared. Well, the square root of 2 squared cancels each other out. So you're left with just the whole number 2. So this answer is 4. Okay, let's try this next one. The side across from 45 is S. The side across from 45 is S. The side across from 90 is S root 2. Again, as soon as you approach these problems, I want you to label it that way. Label it that way. Don't skip that step. Then you're looking for the side where information is given to you. Here they give us the side hypotenuse is 6. Again, I'm going to put an equal sign in between there. So I have 6 equals S root 2. Well, we want to know what S is. We always want to know what S is. That's the relationship we really need to know. So what we're going to do is divide both sides by the square root of 2 so that we can isolate S. S equals 6 over the square root of 2. Now, this situation here, okay, still needs to be fixed because we have a rule that says that you cannot have the square root in the bottom of a fraction. We have to rationalize the denominator. In order to rationalize the denominator, meaning get rid of the square root in the bottom of the fraction, what we want to do is multiply the top and bottom by that denominator. Essentially, we're multiplying by 1 in the form of the square root of 2 over the square root of 2. When we do this, we get 6 root 2 on the top, 6 times root 2 on the top. And then what do we just say? The square root of 2 times the square root of 2 is just 2. Well, now we have 6 root 2 over 2, and we know 6 over 2 is just equal to 3. So this is 3 times the square root of 2. Okay, I know we're going to need to practice this more in class, but it's a good starting place to be able to have some background on what this process is. Okay, so rationalizing the denominator just means multiplying the top and bottom of the denominator by whatever the denominator was. Why do we do this? Because we want the bottom of the fraction to not have a square root sign anymore. All right, let's look at 30, 60, 90 triangles. 30, 60, 90 triangles are the other type of special right triangles. And again, it's going to involve memorizing the relationships. Here we have a 30, 60, 90 triangle. We have to memorize the side across from 30 is S. The side across from 90 is 2S. So the hypotenuse is twice the length of the shortest side. Remember, the shortest side is across from the smallest angle. Now, across from 60, that's the one that is a little complicated with the radical. So it's S times the square root of 3 this time. Instead of the square root of 2, we have the square root of 3. So again, you need to memorize those relationships. Let's try this one. What is the value of D in simplest radical form? So we're looking for D, and we need to find the side that we have information about, and we need to label all 3 sides with what we've memorized here. So the side across from 30, I always start with my smallest. Side across from 30 is S. The side across from 90 is 2S. And the side across from 60, here we have it, is S root 3. So find the side that we have information about. That's 5. That green side is 5. So we can write this equation. 5 equals S root 3. Well, we want to solve for S. So we're going to divide both sides by the square root of 3 to get S all by itself. We have S equals 5 over the square root of 3. Now remember, this is a no-no. You can't have the square root of anything in the bottom of a fraction. So we want to rationalize the denominator. You've heard of a rational number? Rational number is what we're trying to make out of the denominator. That's why it's called rationalizing it. Denominator. There we go. Okay, so rationalize the denominator. You're going to take 5 over the square root of 3, and you're going to multiply top and bottom by whatever the denominator is. So you're going to multiply the top by the square root of 3 and the bottom by the square root of 3. So 5 times the square root of 3 on the top just looks like that. And square root of 3 times the square root of 3 is just 3. Because, like we said, anytime you're multiplying by itself, just cancels out the square root sign. So we have 5 times the square root of 3 is the value of S. And if you look here, that is the value of D also. That's what they asked us for. What's the value of D? Okay, now we want the value of F. Okay, well, F equals twice S. Well, if S equals 5 root 3 over 3, and F equals twice that, we need to do twice 5 root 3 over 3. This is important now. When you're multiplying by 2, think of it as 2 over 1. You're multiplying this 2 only by that 5. because you're doing 2 times 5 over 1 times 3. Multiply across the top, multiply across the bottom. This square root acts kind of like a variable. Think of it as if you were doing 2 times 5x. 2 times 5x is 10x. Same thing with 2 times 5 root 3. It's 10, keep the root 3 the way it is. Same way we kept x the way it was. So 2 times 5 root 3 is 10 root 3 on the top, and 1 times 3 is 3 on the bottom. So your final answer for f is 10 root 3, and s, or d, is 5 root 3. Okay, so over 3. So 10 root 3 over 3 is twice as much as 5 root 3 over 3. Okay, let's look at the next page. What is the length of the hypotenuse with legs of 5 root 3? So this is more practice of the same kind of thing. I'm going to actually save this stuff for class tomorrow, I think. What I want you to work on when you come to class tomorrow, make sure that you know what these two memorized special right triangles are. We've got 30, 60, 90. We've got 45, 45, 90. I want you to make sure that you can label the sides. Okay, so memorize the side relationship. Just a little trick for you. I always look for the smallest angle. The smallest angle is across from the smallest side. So I'm going to go across from 45 and put an S. Across from 45 and put an S. Across from 30 and put an S. Across from the smallest is the S. I kind of like doing these side by side and kind of at the same time. Now, I know that both of the hypotenuses, these two, both have a 2 in them. Here, it would be too easy if this was 2s, right? If we had s, 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 and 2s, that would have no square root signs at all, and that would be too easy. So that's not the relationship. Remember that each of these triangles, 45, 45, 90, and 30, 60, 90, they both have one of the sides with a square root in it. So since this is s and s with no square roots, I know that my hypotenuse has to have the square root. So this is going to be s square root of, and remember, if you remember that both hypotenuses have a 2 in them, this is s root 2. Over here, across from 30 is s. Now I know that my hypotenuse has a 2 in it. That's 2s. So that leaves this side having a square root. So across from 60 is s, and it's a square root, because that's the one that we need here. 45, 45, 90 had s root 2, 30, 60, 90 has s root 3. So memorize these. If I gave you these two triangles when you walked into class tomorrow, I'd like you to be able to label those the way they are. We will work on solving the problems. I know it takes a little bit of practice. Okay, I will see you tomorrow. Thank you.